So following on from the previous example, we were trying to come up with an equation of lines such that the gradient at a particular point, x, y here, is twice the gradient of this line here. And from this problem here, we created we created our differential equation, and then from the differential equation, we managed to solve that anything of this form here will satisfy this condition here. Okay, so now a new problem, a similar one. So given a family of graphs here, given a so this is represents the whole family of graphs here. Okay, well, given this family here, come up with a new function such that the such that it's always perpendicular to all members of this family here. So for example, given this family here, come up with a new graph such that it's always perpendicular to all the members here. So for example, it's at 90 degrees here, it's at 90 degrees here, 90 degrees here, 90 degrees here, and so on. It's always perpendicular. So your new graph, I don't know, it could look something like this. So what is the equation of this this graph here? Okay, so your job is given this family of graphs here, come up with a graph such that it's always perpendicular to all the members of this family here. Okay, so to do this here, well, when given this here, if you differentiate this, it could give you dy by dx equals 2ax. So when given this family here, this will give you the gradient, but then this will also give you the gradient. So we have two ways of finding out the gradient at any point. So this here, we could find the gradient by using this, or we could find the gradient. So when given this family here, we could use this to find the gradient, or we could use this. The advantage of this one here is that well, at any point, so any point on the line, you know the coordinate, you know the coordinates of any point on that line, so you can find the gradient. Well, anyway, when given this here, you have two ways of finding out the gradient, but you're trying to create a graph in such a way that it's always perpendicular. Well, always perpendicular means that well, if you know the gradient, right here, because looking at this here, all you need is x and y. If you know the gradient at this particular point here, then to create a perpendicular version, then you have to take the so here you've got the gradient at that particular point. Say here you've got the gradient. If you want to create a perpendicular version, then it will be the minus reciprocal of that gradient. Okay, so the minus reciprocal of this gradient will give you the perpendicular version at that particular point. The reason for that is because of this. Hang on, let's look at this. Let's look at the gradient of this line here. So here it has a height of 3, the across of 4. Okay, if you want to create a perpendicular line to this line here, well, at the moment it's 3/4. Okay, because the up and down is 3, the across is 4. If you want to create a perpendicular version, it will be the negative reciprocal of this. So it will be, well, turn it upside down and then stick a minus in front of it, because look at this here. At the moment, we want to create a perpendicular version of this line here. Currently, it is 3/4, but let's create a line that is negative 4/3. Okay, so let's just create that negative 4/3. So this will be this here. You see, this line here will always be perpendicular to this line. See, by you creating a negative reciprocal, it will always give you a perpendicular version of it. Hang on, let me do this again. So minus 4/3, so it will be something like this. So this here will always be perpendicular to it. Okay, so the point here is that given given the whole family here, if you so this here will give you dy by dx equals 2ax here. So you have two methods of finding out the gradient. Well, once you have the gradient, if you want to create the negative, sorry, if you want to create a perpendicular version of it, then you need to take the reciprocal of this and then stick a minus in front of it, or this here. So in this case here, if you want to, well, given this here, you want to create the perpendicular version. Well, looking at the gradient here, so let's tidy this up. Let's get the 2 and multiply it to the top. So let's just tidy it up so it becomes this. Okay, so at the moment dy by dx equals this. But then if you want to create something that's perpendicular, then take the reciprocal of this and then stick a minus in front of it. So now hang on. So currently this here represents the gradient of our family here. But then we want to create a new graph. So our new graph must have a gradient of this. Our new graph must have a gradient of this. X, take the reciprocal and then stick a minus in front of it. So our new graph must satisfy this here. Our new graph must have a gradient of this. Okay, we will continue in the next video. The point is that we're trying to create a new graph in such a way that is always perpendicular to all the members of this family here. Well, perpendicular, you've got to take the minus reciprocal of this. So our new graph must satisfy this. Okay, so we will continue in the next video.